Okay, so I'm going to work through the questions from this tough redox topic test that you've done. First question should be straightforward though. You've got molten NaCl, so the only ions in solution are Na plus and Cl minus. And so what's formed at the positive electrode, the anode, so chloride goes to the positive electrode, and then when it gets there, it gets converted to chlorine, gets oxidized to chlorine. And then question 2, which species has nitrogen in the highest oxidation state? So with these sorts of questions, it's really worth going through the oxidation state for each one. So if we take the assumption, as we've been taught to do, that oxygen is always -2, the nitrogen here must be +5, the nitrogen here must be +3, the nitrogen here must be +4, the nitrogen here must be +1. Okay, so this is standard level stuff. You should be able to work that through, and so it must be A, the answer. If you don't need help with that, by all means, go ahead and ask. Where does oxidation occur in a voltaic cell? The oxidation is always anode, because the O is in the middle of the word. That's the way that I've reminded you. Whether it's a voltaic cell or an electrolytic cell, it's always the anode. And where does oxidation take place in a voltaic cell? Well, it's the negative electrode. I guess you've got to learn that. I mean, we've drawn enough voltaic cells showing everything that's going on, so I'm not going to draw that here and now. I think most people got that right, actually. Which is the strongest oxidizing agent out of those? And I warned you there'd be quite a few of these kind of questions, and there were. And lots of you really struggled. This was a real nightmare in the test for quite a few of you, as I suspected it might be. And I think we need more practice. But there we are. We'll get this practiced. So you first of all got to decide which ones are oxidizing agents, and they're the things that are reduced. So it either had to be Al3+ or Pb2+, because they're the things that are going to be oxidized. And you've then got a choice of which one it is. So which is the strongest oxidizing agent? Sorry, they're going to be reduced. Okay, I think I misspoke then. Which one's going to be reduced most easily? And that's going to be the one with the most positive reduction potential. Okay, the potential for the reduction of lead 2+ is greater than the for Al3+. So it had to be that. So what is it? Pb2+. A must be A. Is that right? It is right. Which describes the flow of electrons in a voltaic cell. And again, you've done enough of these. Most people got this right from what I remember. They do flow through the external circuit, so it has to be one of those. And they go from the negative electrode to the positive electrode. Which makes sense, doesn't it? Just kind of got to go to the positive electrode. And then with this question was tough. Lots of people really struggle with this question at the bottom. I'm just going to centralise a little bit. I think I can zoom in with my new camera. Let's have a go. Let's try. I'll just do that. Right. So the way to tackle a question like question 6 is not try to balance it all in one go, which is what many of you try to do. The trick is to split it into 2 half equations, because you're all very good at balancing half equations. So we've got Fe going to Fe3+, and you know to balance that with simply an electron there. So that's that one. And the other one is MnO4- goes to Mn2+, and we know we need to put 4 waters over there to balance the oxygens. We need to put 8 hydrogen ions over there to balance the hydrogen ions. And then we're just going to put the electrons in, and that should be 5 electrons, because the left hand side's +7, the right hand side's +2, so we need 5 electrons. Or think of it as the Mn going from Mn7+ to Mn2+, that needs 5 electrons. So we've got to times that lot by 5 and then cancel the electrons. And then so we've got A is 5. Sorry, yes, that's right. So A is 5. So it had to either be that one or that one. 8 H+. Well, B is not H+, let's have a look. Yeah, B is H+, so it's either that one. So it has to be D. D is the answer. We can just check that's right. C is Fe3 plus, also have to be 5, and 4 waters. Really easy if you split this up into two half equations. Alright, let's look over here then. So, which element has the same oxidation number in both species? Not very easy, I think, to work out oxidation numbers of organic molecules. That's ethene. No, so we're just going to go through all of them. So you should be able to do these. But there's ethene, +1, +1, +1, +1. So each carbon there is -2, and in carbon dioxide it's +4. H is 1+ in water and 1- in sodium hydride. H is always 1+, unless it's H2 the element, or in a hydride when it's -1. S here is +6, -2 for each oxide or oxygen, and then it's got to get up to -2, and this is the answer, isn't it? +6 and +6. H2O2, remember that's the exception. In peroxides, oxygen is -1, hydrogen +1, and water is -2. So it's that standard level stuff. I think you've just forgotten a little bit. Just going to try and refocus this. New toy. That's done well. Try that again. There, that's better. So question 8. 2 cells undergoing electrolysis are connected in series. We've done a few of these in class, maybe not enough, but we've done a few of these. There's quite a lot going on here. So the first step's always going to be the same. So you're told in the question that X grams of silver are deposited. So the number of moles of silver is X over 108. So that's the same for everybody, for each of the answers. So it's still anything at the moment. We then have to work out what the half equation at each in each cell is, or each relevant electrode. So for silver, we should know that silver is silver 1+. If you're not sure, you can work it out from the fact it's AgNO3, but by now you should know that, I'd argue. And at the other electrode, we've got water going to hydrogen ions, oxygen, and 4 electrons. You might have written that like this. I'm going to try to get this right now. O2 plus 2H2O plus 4E. Is that right? 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Right, okay. So yeah, so either way, whichever way you do it, this is the way the IB prefers, and that's fine. There's a 1 to 4 ratio of electrons to oxygen. So this is the number of moles of silver generated. It's also the number of moles of electrons transferred, because silver to electrons are a 1-to-1 ratio. Okay, so this number is the number of moles of electrons transferred. The moles of oxygen produced is a quarter of that amount, so it has to be A. And the time is 22.7. It's just to work out the standard, or the volume, to multiply the moles by the mole volume. That's standard temperature and pressure. Question 9. In electrolysis of potassium nitrate, you've got a gas at the negative electrode. Well, and you've got to say, is that right? You've got to say which is correct. Hang on. Oh, this is how much of the anode. Right. So what's going on in each case? We've got potassium nitrate solution. So at the cathode, you're going to get hydrogen, and the anode, you're going to get oxygen. So there's a bit more. It's not the most obvious question, I suppose. So it's telling you you've got 0.1 mole of a gas formed at the cathode. So that's hydrogen. That's the cathode. You've got 0.1 moles of that stuff. So you need to have these two equations again then, don't you? I'm going to do the simple. Well, let's do it properly. I just paused it to give myself a sec to write it down. So plus 2 electrons. this is not helpful because I'm writing it in the wrong place. So at the cathode, the equation is 2H2O plus 2 electrons goes to H2 plus 2OH minus. In other words, for every mole of hydrogen produced, the 2 moles of electrons are transferred. That's the key ratio. Okay, so we've got twice as much, or twice as many electrons as there are moles of hydrogen. And the other electron, we've only just written that, it's up here, look. So we've got a 4-to-1 ratio. And so if you go from 1, you times by 2, and then divide by 4 to get the number of moles of oxygen. So 0.1 divided 0.1 times by 2 is 0.2, divided by 4 is 0.05. So it has to be either of these two, and we've just said that it's oxygen, so it has to be B. I'm just going to check the answer. It is B for you. Good, got that right. Question 10. Up here, which of these can be reduced? Well, it's all of them. So this is ethene, so that can be reduced, as you know, with hydrogen. And most of you realised that this can be reduced. This is an aldehyde, but we haven't studied reduction yet, so I don't mind that you got this one wrong. But they can both be reduced, and we haven't learnt the conditions for reduction yet. We'll do that in a lesson or two, so you can forgive yourselves, and I forgive you if you got that one wrong. Question 11. Which signs for E cell result in a spontaneous reaction? So delta G is negative. Number of people that got questions later on wrong about delta G. Delta G is negative, it's spontaneous, and it's when E cell is positive. Remember, they're linked with delta G equals minus NFE. So if E is positive, delta G must be negative. So the answer is D. And question 12. Z moles of copper is deposited. I'm just going to pause it and have a little thinking. Okay, a little pause there just to write down the equations. Right, so Z moles of copper is deposited. There we go. There's Z moles of that stuff. And over that time, there must be twice that number of electrons. So 2 Z electrons transferred in that time. In another electrode or another cell, we've got half the current and twice the time. Now, really, they're checking that you understand that the charge transferred is proportional to time and current. So if you halve the time, if you halve the current and double the time, it's going to be the same number of moles of electrons transferred. But the ratio of electrons to silver is 1 to 1 rather than 2 to 1. And so you're going to get, if you have 2Z moles of electrons transferred in twice the time with half the current, then you're going to get 2Z moles of silver produced. So D is the answer there.